Good morning, good evening, good afternoon, everyone, based on wherever you are. Thank you for joining in. This is the chapter 4 of this GBA Enterprise Blockchain series. We have covered a couple of interesting topics, including the cost of ownership, how to design, how to architect, what to take care of, the infrastructure, its importance, and so many interesting bits until this point, which are not just interesting, but are very, very critical, crucial, or you can say uh, instrumental in terms of how enterprise blockchain solutions are to be seen or to exist. Today's topic is, I would not say, is something which is part of the chain. I would say it sits underneath all the topics or the concepts we have discussed so far, or the key factors we discussed about the enterprise blockchains. It's about security and compliance. I'll simply, I'll turn off my camera and I'll just focus on the slides for a bit. Now, security and compliance has been there since ages. It's not that blockchains are the only chains where we are looking at security and compliances, or this is the only technology where it has been talked about or getting the right hype. It has been there when cloud came into existence. It has been there when programming came into existence. Even before programming, in general industry and segments, security and compliance is everywhere. What we are going to do today is to explore how to get more aware about it, what is to be taken care of, how do you cross that line, when do you step back, specifically across different type of chains, different type of approaches, different type of architectures you can take today. We'll not go deeper into technology, we'll not go deeper into programming, algorithms, concepts, because it is just about getting around it, about it, not inside it, because that would be a Bible we would end up reading in the end. Now, trying to create the context about blockchain security specifically, and with security, and every time with security we mean somewhere that we're talking about risk. And it's not just blockchain, like I said. Successful adoption of any technology or operation, specifically the newer technology, is very, very much dependent on the appropriate management of security, compliances, and risk. Now, it's especially true when you talk about technology which is fairly new, like blockchain, beyond complex, and which is not just a sideline technology. It is the core infrastructure of every enterprise which is going to be built on top of it tomorrow. So the key pillars around which it can be defined in some way are confidentiality, data integrity, availability. I'll just simply connect them together, and then we'll discuss more on the subsequent slides on specifics. So we'll talk about what confidentiality means to an enterprise. Now, it's of course driven by the use case. It's of course driven by the nature of the data or the participants. So without answering directly or defining it directly, I'm trying to define it in some sense, that what does it really mean? Then what are you being confidential about in terms of operating? There are only two units which exist: data and the operations on top of data. Now, you cannot define confidentiality without any data, without any participants. So it relates very properly with data. Now, data comes with its own integrity concerns. You would want data to be as accurate as possible, as precise as possible, and as as clear in nature as possible. Then the availability aspect. We'll talk about what kind of risk it can generate if the availability of the whole network, pieces of data, segments of data, participants, identities may not be available at the right time as well, at the right execution as well, or during the right execution as well. So these are very broad level 1, 2, 3s of how do you start creating the context in your end, how do you start your analysis of security in an enterprise solution, specifically, driving it into, a blockchain-based construct. Now, if we get slightly just a bit more specific to blockchains, so 1, 2, 3 was about very generic thought of what is security in enterprises, what kind of things you are looking at. Data is everything. If there is no data, what you would worry about? There is no confidentiality, there is no integrity, there is no availability concern. Everything depends upon data and then on its execution, and then further the outcomes of that execution. But again, data as an input, execution, and then some other data as an output is data again. But then that is very generic. If you add some blockchain to it, what does that really mean? Now we start thinking about how it differs from, or how it depends upon what type of chain it is. It can be thought of differently in a permissive blockchain, comparing a completely permissionless blockchain, because the nature of operation or behavior redefine itself when you put the data into two different type of chains, because their nature is different. How it is different? So again, this is very 101 of blockchains. Everybody know it, but I'll simply reiterate because we are trying to connect the dots here about initially talking on that in generic terms, data is everything. Whenever we talk about security, there are only two things we primarily talk about: data, participants, or you can dilute participants further and say identity or access to that data, because this is how or why we have identities. Now we're talking about that how it differs, the existence of data based on different chains. And this is why we're talking about the type of chains, because based on the type of chains, you could define the behavior of the data. So in public blockchains, like the name says, public, everything is public. Anyone can come in, generate transactions, validate transactions, and of course, what it really means is can access all the data in the world, which resides or exists on that ledger or on that chain. When I'm saying chain, I'm saying ledger, I'm this or that way saying the same thing. Then comes private blockchains. They're restricted, of course, limited business networks. This is how you can define it. Now, private means one single entity or a group of entity in one way or other controls what happens on the network. So you are still having multiple parties, but then you're having the similar ledger underneath, which or where the data exists or would exist. In permissionless blockchains, you got no restriction on processes. What this means is, again, public blockchain, where there is no validity rule around what happens and when. It's about anyone can read, write, execute at any point of time. The execution engine, the virtual machines are always available. Then permissioned blockchains, like private blockchains, they're slightly different. Again, they're limited to a set of people or organizations, but then there are identities which defines who can join, who can execute, and there are specific permissions or rules which need to be followed or leaned upon. So this is how the existence of data differs from different type of blockchains, and this is why it is important to start with this. Start with defining or understanding your type of blockchain, or the chain which you are trying to implement in your enterprise solution. Mostly, it is going to be permission blockchain or a private blockchain, I would say. But still, nowadays, because of side chains evolving in a different way, like we talked about in our last session as well, that how the next generation of blockchain evolution is happening. Private subnets are coming up, app chains, use case specific chains are coming up, while validation is taken care by the relay chains, the core chains, the main chains, the parent chains. There are different nomenclatures for it. There's a question already. I'll pick it up here from Rish. He asks, what's your thought on stock exchanges becoming block exchanges, i.e. blockchain-based financial infrastructure? You know, this is a very generic question and yet a very subjective question. But if you would ask me for my thought, I see blockchain as a core infrastructure to store or for data to exist, and that data is everything. It's the driving factor for any solution, and stock exchanges are nothing but a solution driven by a piece of data which comes in, remains, gets updated, rotates, iterates, manipulates, and then further generates more data. So data and then further data. So I see blockchain or DLTs as one method of re-architecting the way we operate, store, record, resist, restrict, permit, block the data. So I would say that in general opinion, it is applicable. It is as equally applicable to stock exchanges as it is applicable to a supply chain solution. It is all about how you would define different aspects of rules, permissions, business logics, appropriate filters on data, access, permissions, controls, everything. So it does not depend upon the solution. It depends upon how would you architect the solution, what purpose it would fit, and what the DLT has to do with it. Again, we talked about in our previous session, how do you decide if a solution would require a DLT or not, a blockchain or not. So that's a different story. That's a different session. You can go on YouTube and check the previous session as well. I think there is another question about the past session. So I think they're available. Paras, if you're still on, maybe you can help us in the chat with some links if possible. Now, as we talked about chains, we definitely cannot miss football. Football is happening, right? Security is important, but football is equally important. And then we are running a very interesting contest on this. What is happening in the World Cup? Will it be Morocco or Croatia? Will it be Argentina or France? It's going to be very complicated. I've been in Paris like a couple of weeks ago. I know what it means to fans. If you're a fan, even if not a fan, do participate. This QR is right there. I'll keep it on screen for a couple, maybe a minute more. Scan it and follow the instructions on the screen, and you would be playing a very exciting contest. So I say kick it on your phones right now, and then we go back to the serious stuff, security and enterprise blockchain solutions. Oh, please be quick. Some people are scanning already. I know Karthik is doing it, Mustafa is doing it, Aniket is doing it. All right, 30 more seconds and then we move on. This contest is open till 18th December, so no hurry. But 18th is like just right at the corner, so not much of time. So don't be an offsite. Hit the goal right now. All right, thank you for participating in the contest. If you already did, if you haven't done it yet, I wish you luck. Do it whenever you feel like you have time to do it. Now we move on to the serious stuff, which is the security and compliance stuff. So after talking about what the role, what data has as a role to play around security or with security or for security or insecurity, what usually fraudsters do to attack a blockchain solution. Now we are talking in general. We're not talking about that what fits on what type of blockchain. I'm talking about all sort of attacks. We know them already. They may fit some may fit more to public blockchains, some may fit more to permission blockchains, but yes, these are the type of attacks. Phishing is a very typical term, have been there before blockchain. Fintech industry is most afraid of it. A lot of scams have taken place. It's about mimicking the presence of something. So it's been there. We all know it. Routing. It's again trying to turn down the existence of different identities across the internet service providers, and trying to turn down a network using it. 51% attack is pretty famous. It's about killing the majority, or you can say gaining the majority. Killing would not be the appropriate way to say it. And Sybil, Sybil has been, a way of generating multiple identities and trying to, take over the network. So, I'll just be more specific about Sybil because others are more or less, known to you all. But Sybil is interesting in the sense that, in context of a blockchain network, imagine if every node has an identity, every participant has an identity, some sort of authorization on the network through their keys or other ways. Now, if I am running one machine but trying to enact as multiple identities at different times, in trying to be intrinsic in some way about those identities while operating through them, that's what Sybil attack is all about. It's about adversaries trying to be genuine, intrinsic, and trying to come through the identity route, authorization route, the access route into the network. Most of the blockchain protocols today, which we know or have taken care of these common attack types. So we may or may not have to worry about them at all. But yeah, usually when we design enterprise blockchain solutions, this is not about the ledger only. That's why I'm focusing on both the aspects, and I'm talking in general. I'm not talking very blockchain specific stuff, because you may end up thinking of, oh, I have done a China wall for my blockchain layer nodes and networks, but what about the legacy stuff where it integrates or it aligns or it interfaces? What about the general application which would be user facing? What about those things? If somebody could penetrate there, what kind of impact he can generate? So that's why I'm saying phishing may happen on your mobile app or maybe your web app, which would be the user facing one. Now, so you have to think of those attacks in both the senses. Of course, this is not a session for talking about cybersecurity and general attacks on, and the whole era which we have behind us, where, the history has pages written about which attack took place when, what was behind it, what hackers, Russia, Ukraine, China, and whatnot. So we'll not go there. It is just to make you, enable your tentacles, so that you can think in all directions at the same time. Now, we started with data. We started with how data exists on different type of blockchains, how it behaves differently. Now we talked about some general attempts, fraudster attempts on blockchains as well. Now we maneuver a little towards what controls security in blockchain solution when it comes to enterprises. What controls it? What are those factors which you have to classify your framework into? I would say, like I repeatedly said it again, that it is, of course, identity and access management, because this is the driving factor, the authorization, the factor of any business network. And then key management, because this is I would say hand in hand with blockchain. You cannot have a ledger without keys involved into it. When I'm saying key, I'm saying the keys which are primarily used in cryptography, either for transactions, either for identities or some other purposes. And then data privacy. You have to, it has some bits aligned towards the architecture as well. How do you architect it? But again, the privacy of the data depends upon the type of blockchain you have chosen and the kind of risks you might have or you might end up in if you don't, plan it right. Secure communication. Almost all the DLTs are peer-to-peer in nature in terms of, how one node communicates to other, how data propagates, how blocks propagates, how validation confirmations propagates from one node to another, even using the gossip protocol or whichever internet layer underneath. It traverses from one peer to another peer. So that communication must be secure. If there are any developers on the call, I would say they must be aware about libp2p as a library, and libsignal as another library, which Twitter is also planning to use now for peer-to-peer direct messaging. In smart contract security, this is something, how can we not touch it? Every time somebody says blockchain, smart contract comes in as a follow-up. Like, you cannot complete enterprise blockchain solutions without smart contracts. Of course, it's not a cryptocurrency, right? It's more than that. You are not simply doing, you're not simply writing on the ledger in general way, you're writing complex business logics as well. So smart contracts comes obvious. What they have to do with security, we'll talk about it later again, but I think I'll give you a glimpse of it here as well, that smart contracts are nothing but some piece of code. People who understand blockchain, they would understand how they are laid out in terms of where they run, where they execute, how are they treated. But then there's still a bit of code, and they have vulnerabilities. Vulnerability means risk. Risk means you have to think of security. And then transaction endorsements is the last point. Now, knowing all those factors, how do you classify? So, sooner or later, we're going to talk about a framework. That's how we are, progressing in this conversation. Now, Aniket asked a question. So, I think before going into the classification of, what we have seen about data, the types of blockchain, the factors, and how do you control your security aspects using those factors, I think we should take this question from Aniket, because it says blockchain is known for data security, but we see many hacking news. They hack exchanges and all. How does it happen? It's a very generic question. I can talk about specific hacks though, but like I said, blockchain is not going to do magic if you have weaknesses. It's just pretty simple. I'll give you some examples which would help you relate. So specific to exchanges. Now, most exchanges are centralized exchanges. That's it. I think we should not even have further discussion. FTX debacle is the latest example of what happened with the CFIs, centralized finance instruments or solutions. You control a limited set of infra because this is how it runs. A centralized infra, you attack it, you gain access to it, you turn it down, you impact millions and billions. So hacking a centralized infra or exchange is pretty similar to hacking any centralized system out there. Like it has been happening for, like I said, decades, right? Era almost. And there is a history. Hackers have been magical, instrumental, phenomenal, I would say, and sometimes and almost all the times with style. And that's why they've been in news. So hacking exchanges is pretty similar to hacking a centralized system. Now, how do you hack a decentralized system or decentralized exchange? Again, depending upon how it is built, I can attempt a Sybil, I can attempt, a 51% majority attack. I can create Sybil and create, a subset of the chain which acts like it's genuine, tries to enact as it is genuine, try to generate a fork out of it, which then is, if taken as the primary chain, makes a lot of impact. So there are ways to do so, and that's why we're talking about this security and compliance aspect. But exchanges has everything to do with the public blockchains in today's time, and maybe the way you've been asking this question. If you talk about enterprise blockchain, this theory changes a lot, and that's where the current slide where we are, it talks about the classification of what considerations you should be taking in specific to enterprise blockchains, not going to be 100% applicable to public blockchains, but some factors, if you would consider, will apply there as well. Now, 1, 2, 3 are standard risks, smart contract risks, value transfer risks. Blockchain is all about value transfer. This is how I see it. There was this question in general in the very beginning, that how I see stock exchanges. I say value transfer, that's it, nothing else. So these 3 classifications can be done. I'm not saying that what we are saying today is the eternal truth. It's just one way of thinking about it. There could be better ways, and this technology is improving and again changing so fast, both improving and changing. I would say that you have to consistently keep building up ideas about security, keep analyzing, keep defining approaches about security, and keep reshaping your strategies around it. So let's get into the risks. Now, standard risk can further be divided into so many types. Of course, your brain would start thinking right away as you see those keywords, but we would go to them one by one in some sense. So strategic, what hits in my head, the moment I read it and I try to connect it with blockchain, it's it's to the first time, when a firm needs to evaluate. It's that thing that whether they would want to be at the leading edge of the adoption or wait to adopt until the technology matures. So you cannot simply jump into a technology because it is there. You have your strategic priorities. You got it, and you may not be the only one which gets impacted, specifically in enterprise blockchains. I'll give examples which would fit into multiple failures in the real time, which happened very recently as well. So if there is a consortium of telecom companies, for 3, something must be a priority. For example, fighting these spams. But for 2, fighting interconnection charges is a priority. Now, their strategic priorities don't align. So you have to be very aware of if your enterprise and the enterprises in the consortium, which are going to be there if not there today, are they aligned strategically towards the use case properly? Because if you would apply it tomorrow, they might simply say that, oh, you're not getting the right value out of it. Oh, this is what not we thought would happen, and the solution might not be a global scale solution, or some participant out of the consortium would simply bail out. And when they bail out, the consortium fails because some would say, oh, I cannot bear the cost of running it. There are complications. We talked about those kind of complications, costs, architecture and design complications in the past webinars. Go back, do go through them. So strategic challenges are those. Now, business continuity and reputational, I would combine them, and I would say again, giving one example for strategic, business continuity, and reputational, all of them together. If you have heard of TradeLens was a consortium started by IBM and Mercer in 2018. It's been 4 years. It's quite a time for any consortium. It's being shut down now, and this consortium came into existence because they wanted to digitize and simplify the global supply chains. And supply chain challenges are known to everybody. Specifically after COVID, it skew in a direction where nobody could not think of that if there are challenges in supply chain or not. So this TradeLens consortium was focused there, but then it is shutting down today. It has been declared by IBM and Mercer jointly in their notices that this consortium is going down. Reason being, because they did not get the right global industry collaboration. Now, what I talked about in strategic, you see one mistake turning into another. So if you do strategic mistakes, that's of course a risk. Your priorities may not align with the other enterprises' priority in the consortium, but then it would again do a drill further when it comes to business continuity and reputation as well. And then there are general other standard considerations which you need to take. Information security. This is something which you just cannot dodge or avoid, and you cannot simply let it to the old existing legacy exercises of Web 2 world. It has to be rethinked. It has to be redefined, rediscussed on how information security should be achieved in these kind of solutions, which are having different formulas, different functions, different behaviors. Regulatory aspect is the one most talked about in enterprise space. What if tomorrow what I built upon today would not be accepted by the regulators, or some regulation would be there by the government? For example, nobody today knows what happens in India, or what happens in US, or what happens in Europe. Would a CDBC exist? If it exists, what kind of regulations would be around it? What if some government passes some new rule or new ordinance and changes the way it can be adopted? So you might build something today, but then regulations would come in and change everything for you, specific to enterprise business. This is something we must take care of it. Ops and IT, like information security, is pretty much common. You do not do it the old way. You do it the new way. About the infrastructure, be it about the management, monitoring, analytics, proactive alerts, be it about uptimes, be it about SLAs. You gotta be at the verge of falling. This is what risk is. If you don't do it the blockchain way, if you do it the old way, the system may still be prone to big risk. Contractual and supplier are pretty much the same. So the business contracts, they happen in a way. Now if you cannot formulate the same in the chain, and if there are gaps, then the system would be at a big risk. And how do you enforce contracts even if you define them right? And supplier, it's not about the supplier in the supply chain. It's about, if I'm an enterprise, I'm getting it built, and one of you is the supplier who's helping me build the solution. I'm completely dependent upon you, and there is no internal expertise available. So that's where the risk becomes very, very open. Coming up to smart contract risk considerations, this is about business and regulatory, legal liability, enforcement of contract like we just talked, information security like we just talked. Now, smart contracts has got one very big problem. I'll talk about a real world example. I think that would help you connect well. Smart contracts, like we discussed, they are business logics. What they do is operate upon something. They have fixed rules defined and all. They operate upon the data which they have been given through the ledger. Now, in cases of enterprise grade solutions, there are a lot of legacy systems. There are a lot of Oracle services which are coming, which are being used, which are the input to the contracts at time. You see, there is an external input to the contract. Now let's take an example of a Hollywood movie which you must have seen already, where a heist is being planned, and there is a hacker in the team. Now, what that hacker has to do is to make sure that when the team comes out robbing the bank or the institution, the traffic lights, I'm saying, turn in their favor. Now, if this traffic light is seen as the validity rule, the driving system for the city, where everybody follows the rule, no accidents happen if everybody simply obeys them, right? So every car turns left when the turn left is green. Every car goes straight when the goes straight is green. When it is red, they stop. When it is orange, they slow down. Now, if the hacker starts playing with the lights, we have seen it in the movies. The cars, it's just chaos everywhere. I would say chaos everywhere. Everything starts banging into every other thing. Every car damages the right when it's taking right. The left is coming straight. Nobody is stopping for nobody. So chaos everywhere. Why? Because the traffic depends upon the light. It's a signal. It's a trigger. It's a trigger which they follow. Now, if this trigger comes outside of the smart contract world, the data which is outside an Oracle or maybe a legacy system, somebody hacks into that system, tweaks the data to favor the contract in his own way, or let the contract favor him. If a variable is taken into account for some calculation into the contract, or maybe some decision-making trigger to trigger another contract or execute another contract, then it's a domino effect you're looking at here. That's what happens at the traffic lights in those Hollywood movies. Domino effect. You just cannot stop it. It just keeps on and on and on at an exponential rate, and it can be catastrophic, undoubtedly. So smart contract risks are huge, and if they're not taken care of right, they become a liability, and then in turn pretty soon a legal liability. And businesses, if the business logic or the business contracts are not well juiced up into the contracts, if they're not defined all in the contract, then things go very wrong. Now, value transfer, we said like everything is a value transfer in the blockchain system, be it this or that or them and those, but in the end we always talked about value chains, value transfer. But what are the risks to that? If TLT is there as a fundamental ledger, as a saving grace, as an answer to every question we ever had about risk, compliances, security challenges, but then in the beginning we talked about that if there is a technology, there are nuances to it, and you cannot have a technology without nuances to it. Now, I'm talking about technology because these points, they mean technology, right? When you hear consensus protocol, you do not say business. You say technology, it's a tech term. But what can happen to a consensus protocol? I'll give pretty straightforward examples. We all have heard of PBFT algorithm, the practical Byzantine fault tolerance algorithm. Now, it requires parties, which are participating in the consensus to agree on the exact list of participants. Exact list means, who would be the participants, and not just participants. Membership in the system is set by a central authority or some sort of, closed group regulations. So this is the weakness of this protocol. If you go if you drift a little towards the public protocols and talk about proof of stake, POS, also known as POS, then this protocol or this consensus algorithm, it is possible for block generators, people who are generating blocks. They can vote for multiple block generators. Validators can be multiple in the same round, and if they are chosen, it would turn into a situation where forks or multiple histories of the chain might take place. And when that happens, boy, that can be very complicated. That which chain is right, and again, Sybil attack, they are very similar, or they have a space here available for them to take place. So if there is a history of chain which is created, if there is a fork of chain which is created, ultimately what you're not having is you're not able to complete the transfer of value in the end. So we have to be very sure about what consensus protocol is part of our game or the solution. Again, if you want to go deeper into it, what to choose, why to choose, when to choose, I think the previous talk about the architectures or designing a solution would fit, and you must listen to it. You must listen to it. Key management is the primary aspect, because anybody who controls the key controls what is done using the keys. It's like if you control the key of your house, you can control what happens inside, what sits where, and why, and if it is to be taken or given to somebody without permission or not, because key is the permission. So when I'm saying without permission, it means if somebody has got access to your key, he's doing it or she's doing it without your permission. But then key is the definition of the permission on the ledger. So ledger would always say that you have done it. So key management is the primary aspect. And there are plethora of cases where if the network was, I still remember the famous X0 hack, if the network is of like limited nodes and you attack into some nodes, you get access to the keys, then you not just have the majority, you also have the power to execute, which is the most dangerous bit. Having the majority would allow you to rewrite everything, but even having access to keys, now the risk is equal in both the cases. We've been talking about the risk if somebody gets access to your keys, kind of an attack scenario where somebody maliciously get access to your keys through some backdoor, Trojan, some other way. But what if you lose your key? That's also a risk. And you don't want an enterprise solution. It's like we cannot even afford to lose our wallet in today's time. We go crazy if that happens. We lose our phone, we go crazy, right? Imagine an enterprise solution where businesses, millions and billions of dollars of business is happening every month, and somebody loses the keys, some machine, some node, some individual, some participant, some ID member loses the keys, or the keys got compromised. In both the cases, the risk is catastrophic. Liquidity, it's specific to, I say, fintech systems, because banks and fintech institutions, financial institutions, they saw it this way. If there are intermediaries, which blockchain kills primarily as the first target, then you have who might fall into liquidity problems because nobody controls nothing. It's the keys, the people, the identity. They control everything. Now you cannot regulate it without regulating it. And if you want to regulate it, you need people who can decide and change and decide and define and execute. So, but if you do so, you define or you again, set a boundary and appoint a limited people or maybe an intermediary to do so. Again, creating a risk, and it's a trade-off again on both sides. On one side, you're placing back the intermediary. If you're removing it, you're challenging or you're creating liquidity risk in the system. So it's a two-edged sword, I would say. Now, 10 enterprise blockchain implementation risks to consider. So apart from those classifications, what are those, if you would count on fingers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, what are those factors? It would include programming, cybersecurity. It would include general aspects as well. So I'm not going to get deeper into each of them. It is just list down, and maybe I would say, this is a list which is just to start with, is there. You add 20 more points to it when you get to the solution. You are architecting, or you're designing, or you are participating, or analyzing, or defining. You create 20 more points next to it. Talk to experts, talk to people who know about it, talk to people who are working into it, talk to people who are coding it, talk to people who are testing it, talk to people who are defining the regulations around it. So consider all sides, go 360 degree. Don't just focus on technology, don't just focus on business, don't just focus on regulations, don't just focus on compliance. Just go 360 degree and list 20 more. I think that's a food for thought. But yeah, if you have no time, at least consider these 10, if not 20. Now, funneling everything down to this, whatever we have discussed up to this point, the four beams on which, the foundation of a management framework can be created. A risk management framework, I'm being specific here, can be created. So starting from the business objectives to the processes which are there, and then the risk considerations which we categorically defined about, having their own importance in terms of securing an enterprise solutions and mitigating those risks. And then further, what kind of operating models we are looking at. Governance, of course. Every time we talked about people regulating, multiple parties, consortium, we're talking about a very strong, clearly defined and executed governance model. We're talking about policies, we're talking about standards, we're talking about management processes, we're talking about business rules being accurately and absolutely being translated into smart contracts, so that when the execution happens without any intervention, it happens right. We talk about tools and technology which ensures your network, your monitoring, your performance is being taken care of, and it's safe from majority, it's safe from performance, it's safe from civil, it's safe from other aspects of the infrastructure challenges. And then reporting, and this comes obvious. You won't know nothing if you won't measure, if you won't put it on the screens, big screens, if you won't generate triggers, notifications, alerts, the information would be of no use. It would be, because in these kind of scenarios, it generates very fast. It generates at a rate where you cannot handle it. And then the culture, it's the heart of everything, I would say. What are we doing today? We're trying to drive a culture out of a conversation. We're trying to define what we need to do to become risk averse. We're not trying to fix risk. We're not trying to do statements or talk statements about what is right, what is wrong. We're just trying to be risk averse by defining a risk culture for ourselves. So for me, that's the most important bit, right? Bottom. If you don't do nothing, just start focusing on how do you define your own risk culture, and everything would come in obvious to it. These are the obvious ingredients. A risk culture needs to be defined. Now, tips and best practices. All I'm trying to do here is to help you out in a very quick possible way. If you don't have much time, go by these points. But again, this is a segment where don't follow this discussion. Do not follow. The technology is changing very fast. Protocols, consensus, algorithm, regulations, compliances, they're changing very fast. Peer-to-peer communication protocols, algorithms, cryptography, key management system, they're changing very fast. So just don't focus upon this. Define your own items, analyze your own lists when you get to the point. But yeah, still, what kind of key questions would help you do that? One, you got to ask yourself, what is the governance model for participating organizations or members in a consortium? We are focusing on permission blockchains which help enterprise build better. What data would be or will be captured in each block? This is very critical, but again, this has strong connections with the architecture discussions, because you cannot make a blockchain bulky, because when it becomes bulky, it becomes slow. Slow means it is prone to some sort of attacks again. And then what are the relevant regulatory requirements? If you don't know that, you might create business continuity risks of tomorrow. Aniket, I'll come to your question, but I think we'll run through these points first. How are the details of identity managed? Again, data is data, but then when data is controlled by people, then identity matters, or participants in identity matters the most. How it is managed, how it is handled, it's as equal as important as as the data itself is. Then what are the disaster recovery plans? Now, this itself is a very disastrous question, considering people usually say that blockchains or ledgers are highly available, they have redundancy, they are replicas and all, but not enterprise blockchain solutions. When you can define the permissive nature of it, who can store what, and selective data sharing and all. What is the minimal security posture for blockchain clients for participation? What is the logic for resolving blockchain block collisions? So these are, I would say the hot questions which you must ask to define, and then start, filtering everything through the framework, risk framework, to at least ensure that you are basically covered. I'm saying basically covered because things are changing damn fast, and you cannot keep up with the way that things are changing until you start analyzing, reading, studying every other day. Now, coming to your questions, Aniket. So Aniket asks, 1, can machine learning be used to detect and prevent malicious activities on a blockchain, such as hacks, data breaches, and fraudulent transactions? I would say machine learning can do postmortems. It can read the data, ledger, key usage, participation, this and that and whatnot, but then it would give you predictable inputs, not as accurate as possible or as accurate as they have to be. But then it's a preventive measure, right? It's a preventive way to define what can happen in future, learning from the past. Security is not something you would want to leave it to that, I must say. But then, yeah, it's an interesting topic. There are solutions which are learning out of, the attacks of the past, the scenarios, the behaviors of the past, behaviors of data, and the identities combined and standalone both. So these are there are algorithms which are learning from that, and then they're predicting what can happen in future and trying to prevent as well. And then Aniket further asks, if yes, then how can we use machine learning to improve the efficiency and effectiveness of security protocols and measures on a blockchain platforms? I think it's pretty general. We answered it already. So I'll simply move on to the next slide, which is about solutions to resolving blockchain risk and ensuring compliance. Now, we talked about the tips and tricks, we talked about the pillars, we talked about the key factors, we talked about the questions you got to ask. Now let's talk about some solutions as well. Now, we talked about a model, right? So you have to develop a risk model which fits the target cases, the target scenarios, the target architectures of yours, or target businesses, or fit to the governing model, the programming, the technology, the protocol, the consensus. So you have to define a risk model. Second, enforce security controls that are unique to blockchain. Now, we're not talking about username passwords here. We're talking more than that. So this is just a hint, how you can think. Apply conventional security controls. Of course, you cannot leave the username passwords behind. You still have to consider them, because when you would project this application towards some users, they have at least some sort of access. Key management would come in play. Normal user behavior, operations, security aspects would come in play. Standard, DDoS, DOS attacks, those kind of scenarios, traditional cybersecurity challenges would come in place. So don't ignore them thinking that, oh, I'm doing a blockchain solution, what I would do with standard cybersecurity stuff. That's a must anyways. So don't leave that aside. And then enforce business control for blockchain. If you would take in, at least these 3-4 measures, I think you would be well covered. That's it for today. If you got questions, punch it. If you got challenges, join us later in the next sessions as well, or maybe write to us later as well on different channels which you can access us through. And I think we still have one webinar available, which is going to be happening next month in the enterprise series. Do join that as well. And again, I'll in the last, I'll just open up this contest again. If you love football, don't miss this. Give yourself a fair trial. And that's it for today. I think this is my best performance so far. It's still 7 minutes to finish the session, and I've actually reached the Q&A, even doing Q&A in between. So thank you everybody for joining in. Do get into the past sessions through YouTube links. Do join us in the next session as well. Participate in this contest. You would love it. If you are a football fan, if you're not a football fan, still do it. All right. Thank you, everybody. Have a nice evening, morning, afternoon, and see you in the next session.